So Chris is joining us from Rochester. You're currently in Rochester, right?
I am in Rochester currently, yes.
And
Not
he's
quite as warm.
it's so hot here as well. I thought, yeah. And he'll be telling us about high resolution flexography for the manufacture of transparent heaters. So when you're ready, please share your slides.
Okay. So good afternoon, good morning, everyone. Evening if you happen to be in Asia. So I'm going to focus on an approach we take to manufacture heaters using a fully additive process. I don't need to go into this in detail. Obviously, I think everybody in the conference is aware of myriad of applications possible for heaters, specifically if they're transparent. Everything from, like we just heard about, for automotive ADAS systems seem to be kind of the hot topic these days for us in terms of interest in the heaters. But a lot of other things in terms of eyewear and medical devices is also a pretty popular topic these days. So I'll get into a little bit more detail, and just to describe at a very high level the process we're using and why I say it's fully additive. What we're doing is we have a system where we can address down to 2 micron resolution to create flexographic printing plates. And then that gives us the ability to pattern the plate essentially, free form in any kind of pattern you want. So, one of the ways we're accomplishing this for heaters is doing a microwire mesh. We're doing that in a roll-to-roll process. So it goes through, again, we'd use the plates more or less as your tool. And then it's going to go through the press. We're printing a catalytic ink, a seed ink that actually then facilitates an electrolysis plating process post-printing. So we're printing and then plating. This is all, again, in roll-to-roll inline process. We take it through this electrolysis plating process, which deposits the copper wherever you happen to have the catalytic ink printed. So whatever pattern that is now starts building up as a copper pattern. And then we have some post-process capabilities in terms of testing for optical, electrical, singulation, etc. And you've heard us talk in the past, perhaps, about other applications we've used this manufacturing capability with. More specifically, capacitive touch display panels and transparent antenna. So this slide here just shows you, just to kind of set the stage for the level at which we're actually creating these patterns and these micro wires. You can see that by the 3 columns here, these are actual micrographs, by the way. They're not drawings of these grids. But we have we can vary the grid based on, the need for sheet resistance, essentially. So we can vary the width of the line or the pitch, the distance between the line, as well as the amount of copper that's deposited. And you'll see here down at the bottom a cross-section where you have, we printed on a PET substrate, the catalytic ink as the first layer, then the copper is grown. And then we do apply a darkening agent or a passivation layer that does protect the copper from oxidation, but it also gives it a nice neutral gray color. And we have that neutral gray on both sides of the film. Since, again, we're talking about transparent, you're not going to see a reflective copper underneath looking from the back side or above from the top side. And you can see here the various sheet resistance levels. We can get quite low for areas where you're going to actually do your bond pads or bus bars, etc. And maybe when you're in a more sparse area, of course, that the resistance is going to increase somewhat, but still quite low, significantly lower than you achieve with typically a printed ink conductor.